Hello, everyone, and welcome to today's webinar, How NOVVA Data Center Achieves Zero Downtime with Controller Modernization. My name is Mallory Millen, and I will be your host today. We're excited to have you with us. Before we dive in, here are a few quick reminders to help you get the most out of today's session. All participants are currently muted to minimize background noise and ensure a smooth experience for everyone. Please use the Q&A function to submit your questions at any time. We'll address them throughout the presentation and highlight a few live during our closing Q&A session. We'll have our data center technical expert, Fred Ross, on the line during that closing Q&A session, available to answer any technical questions. And if we don't get to your question, we will make sure to follow up with you directly afterwards. Now let's talk about how you can participate. We'll be launching a few poll questions during the session to better understand your needs. Your responses are greatly appreciated. At the end of the webinar, we'll also ask you to complete a brief survey. Your feedback helps us improve for future sessions. And lastly, today's webinar is being recorded, and you'll receive a link to the recording within 24 hours. Next, I'd like to introduce you to the NOVVA Data Center implementation experts from Siemens and Holbrook Service, who will be sharing more about this exciting project with you today. Lava Pokala is a strategic growth manager at Siemens, where she leads data center solutions within smart infrastructure building automation. During her time at Siemens, she has established herself as a leader in product development and strategic management for key growth areas. And our special guests today from Siemens partner Holbrook Service, David and Vanessa. David Carpenter has been with Holbrook Service for over 10 years, working to differentiate them as a leader in the building automation field. As a Siemens partner, he enjoys offering customers leading-edge building automation system solutions to drive dramatic results. And Vanessa Lucero oversees development, installation, maintenance, and troubleshooting of commercial HVAC building automation systems for Holbrook Service clients in industries including data centers, healthcare, commercial, and more. But first, before we get to the agenda, I'd like to take a quick poll question so that we can learn a little bit more about who is on the call today. So I am going to launch the poll question, and the question is, what is your role? And just submit your answer here. Take a couple seconds, and then we'll move on. Okay, I see some coming through. That's great. Okay. Looks like we have, oh, it's changing as I'm talking here. 52% of the audience is engineers. We've got other and contractors and controls technicians. So that's great. We're happy to have you guys here with us today. And then I just wanted to run through the agenda with you, and then I'm going to turn it over to our first speaker. So we're going to kick off with an overview of the current trends in the data center market, and then we'll dive into the heart of our presentation with David and Vanessa, who will share with us how Holbrook Service successfully modernized NOVVA Data Center's legacy building automation system infrastructure using Desigo PXC controllers. After that, we will provide a brief overview of the Siemens Data Center redundancy solution, along with tools and resources to help support your journey. And finally, we'll wrap up with a question and answer session. And with that, I'm pleased to hand things over to our first presenter. Lava, please take it away.
Thanks, Mallory. Hello, everyone. The data center market is booming. There's several trends that are creating tailwinds for this industry, starting with corporations migrating to cloud IT from on-premise servers for the past 15 years. The newest and largest boost is coming from artificial intelligence and the data centers that are being built to support this technology now and in the future. High power and water use in data centers is creating a focus on sustainability and the need for older data centers to be retrofit with better infrastructure that supports sustainable systems. And also the rise of new renewable energy sources are happening for data centers. New segments like edge data centers are catching on soon to support 5G autonomous cars and IoT technologies. And finally, data center data sovereignty measures are changing the data center to be built within the countries. All these trends combined are creating a huge demand for data centers. Let's take a quick look into the data center segments by ownership. There are different ways to segment this market, but when we look at it from an ownership viewpoint, we have the hyperscale data centers that are owned and operated by the company that builds them. They're massive and they're getting denser with AI growth. Scalability, flexibility, and speed to market are key for this entity, and they're usually built in phases that begin with minimal infrastructure to keep early investments as low as feasible and expand as needed. And the next big chunk is the enterprise data centers that are owned and operated by a single organization to support their IT needs. They're purpose built, they may be on or off premise for the company's internal data. Corporate companies, banking, financial, insurance, all these are typically the ones that build their own data centers to protect their digital business and keep data secure. Co-location data centers, the one we'll be talking about at NOVVA use case today, is an example of that. So data center operators build and own these co-location data centers, and end users lease to scale up or down as needs change. Retail, wholesale, startups, all of these lease these rack spaces, and they're typically found in the suburbs of big cities. Carrier hotel is a niche category, and these are interconnected downtown data centers that are mostly built in old buildings that are hubs for power fiber connectivity. They operate in a highly competitive and rapidly evolving market in city centers. Edge and micro, these are small data centers located near the people and provide lower latency and reduced communication delay. They usually leverage existing building infrastructure and reduce capital costs. Typically, they are small with 10 to 20 racks and between 150 to 300 kilowatts found in company parking lots, under cell towers, and high density areas. The global demand for data centers is expected to triple by 2030. And to avoid a deficit, at least twice the data center capacity built since 2000 would have to be built in less than quarter of the time. That's fast, and that's a lot of demand. AI is the key driver for this demand, and by 2030, 70% of this demand will be for AI processing power. Today, majority of these AI-ready data centers are built and owned by cloud service providers such as Amazon, Google, Microsoft, and so on. As AI technology matures, demand for private hosting is likely to increase as more enterprises are likely to build and train their models and create their own models for their internal data. Now let's look at compute power. That's also another change that is happening. Compute power and rack density of data centers has triggered the evolution of cooling technologies to support heat removal. 10 years ago, when rack densities were 3 to 5 kilowatt, crack units and air handling units were sufficient to effectively remove heat. But the compute power of chips has since evolved, and with GPU chips used in AI data centers, rack densities have reached up to 200 kilowatts. At this juncture, infrastructure is being updated from air to liquid cooling. Newer cooling technologies such as the rear door heat exchangers, direct-to-chip cooling distribution units, and liquid immersion technologies are increasingly being adopted to cool the high compute GPU chips. Now, before we dive into the main topic, where David and Vanessa are going to talk about how NOVVA Data Center achieved zero downtime, we have a poll question for you. Is your IT department planning to increase the power demand at rack level? If so, do you have plans to optimize your building infrastructure to adapt for the higher loads? Let us know. Yes, no, I don't know. All three are acceptable answers. So take a couple of seconds. Right, should we transition to the next topic? David and Vanessa will be talking to us about how Holbrook helped NOVVA achieve zero downtime. David and Vanessa, off to you.
Good morning, everyone. I'm David Carpenter, Controls Manager for Holbrook Service.
And I'm Vanessa Lucero. I'm the Controls Technician for Holbrook Service.
So as we talk about this retrofit for NOVVA Data Centers, this was a building that NOVVA had acquired and was existing. So while we're talking about specifics in the migration of controls that we perform for them, we understand that every building is going to have unique demands, different equipment. As Lava just pointed out, there's a huge difference in rack densities and what cooling is required. So we're really going to focus on some things that will translate from one building to another and focus on the redundancy and the need for planning in making these changes, whether it's a retrofit to an old building or it's a purpose-built new building. So some of those challenges is when you have an old building with legacy infrastructure.
Can we go back? Sorry. We'll also be talking about the steps that we took for modernization in the planning aspect of it, and we'll talk about the process we took to maintain zero HVAC downtime in a 24/7 environment, but also why redundancy is so important in all of the plant equipment.
And while redundancy in controllers doesn't in itself produce energy and utility savings, maximizing the programming and using tools that are available in modern infrastructure for automation can produce some utility savings. It can maintain the building better, streamline maintenance, and using tools like BACnet SC, enhance security and sustainability growth for the future. So we'll get into some of the challenges specific to this site. Next slide.
One of the challenges that we frequently see on not just this site, but many of the sites is old wiring or old labeling. A lot of the panels have undocumented wire changes that have happened through the years, or the handwritten wire tags have been worn off. So it's not trustworthy in order for a replacement. Another challenge that we have run into is the frequent equipment failure before our change out. This causes problems with scheduling, with budgeting, budgets for service calls, replacement parts can be expensive, maintaining consistent temperatures of the server floor. All of this causes stress on the mission critical team, especially on nights and weekends when there is less personnel available. So the many service calls can be an issue. There's cost associated with it. There's cost for the parts. It means that you're playing catch up to fix and identify the problems, and that's not a very proactive approach to running a building. But we also knew that we needed to maintain all the temperatures on the server floor throughout the change out. That was very, very important. We couldn't mess with any of the temperatures. So all of the mechanical equipment needed to stay running to maintain the server floor. And then the old MSTP architecture of the old system, it was slow responding to failure symptoms. So this means that the mission critical team was responding to warm supply temperatures, and that took time for the symptoms to appear instead of them knowing at the time when a failure happened.
So with the change outs, of course, we need to have an N+1 in the mechanical cooling equipment as a minimum, just to make sure that there's an option for replacing a control panel, rewiring sensors, outputs, so that a single piece of equipment can be turned off while we're working on it and still maintain that building. Of course, having a more dense redundancy than N+1 is ideal, so that there can still be a lead lag function that's operating during that change out. Minimizing the time that it took to replace a single panel was important so that we could get a panel back up online and maintain that redundancy that NOVVA's customers expect from them. And as we talked about, looking for ways that we could reduce energy usage and keep the PUEs of the buildings reasonable and attractive to customers. Next slide.
So we took time to plan, we took time to think about our plan, and then we took time before we were on site to do a lot of prep work. So in the planning stage, we knew that there was no downtime. We could not be afforded downtime. So as with, I'm sure, many of your sites, you can't just turn off the mechanical equipment. It meant that the plant equipment needs to continue running to maintain the server floor and the temperatures. So this takes time to plan, of course. We also needed to determine our customers' needs. So there was a conversation between Holbrook and NOVVA as to the redundancy, the mechanical schedules, the server temperature requirements. All of that was a conversation between us to come to an agreement. And then we took time to pre-program off-site, and it took thought, care to intelligently program the controllers according to what NOVVA and Holbrook discussed. By programming off-site in our office, it means that we didn't take any equipment offline before the physical changeout, and it allowed NOVVA to access all mechanical equipment for a longer period of time that we're not programming on the live equipment.
And with that pre-programming, one of the tools that Siemens offers in their ABT suite of software is that we can simulate every program, even simulating multiple controllers at a time, so that in our lead lag programming, we can debug, make sure that it's acceptable times before a piece of equipment is able to pick up, and be able to see not just from a physical failure, there was an IO that turned off, there was an output that failed, or a piece of mechanical equipment that failed, but now on the IT side, every controller is aware of who else is operating, and we could simulate failures of communication and what the response for the controller would be. That meant we had peace of mind in deploying that piece of equipment into a panel before it ever made it to the job site. This meant it was ready to go. Once it was in the panel, another tool that ABT with Siemens software has is we can commission every single point, and it produces a commissioning report for peace of mind for the customer. This shows all of the facets of every point, what was commissioned, if there's any offsets, or if there's any problems with that point. That way in the future, there's no confusion about anything that physically went in. And then ultimately at the end of that, we have to plan on being able to lead lag the equipment in real time, so that we can see how it's going to respond.
We were able to achieve zero downtime by taking time to prep work, Like I had said, we had pre-labeled all of our wires, we traced everything out, we pre-programmed in the office. So all of that prep work really all came together. Despite having redundancy, we wanted to make sure that the equipment was offline for the shortest period of time possible. So once the equipment was offline, we were able to complete a panel change out, a controller change out in an 8-hour workday. It meant that NOVVA had all their equipment at their disposal again before the end of the day. And so the need to keep the heat load for the server floor comfortable, we knew that it was set within the temperature range, and the redundancy played a key factor into doing this.
And having an N+1 is critical. On this particular site, NOVVA had N+3. And so we could still maintain a lead lag in one chiller plant while having one of the pieces of equipment in the other chiller plant down. That meant that they were able to have a little bit of peace of mind, but during the change out, those were operating on the failing infrastructure, the MSTP network that was giving false alarms, having communication problems. So we wanted to minimize that changeover. As soon as there was actual equipment hooked to it, we wanted to sequence that lead lag. And that's important because the pieces of equipment as pictured here, this particular site was carrier centrifugals, 750 tons, 4 of them. And every piece of equipment is going to have its own startup minimum times, times that we want to see it operate, etc. And make sure that those are all in line with the operating plan for the customer. And then we can troubleshoot that. One of the things that is very important in a critical environment, especially a data center, is that all of the control panels are powered by the building's UPSs and generator backups. That may seem like a no-brainer, but that's not always the case from an older building. And so it is something that we want to make sure we never see a controller having to reboot because of the downtime in between a generator kicking on. That would create false alarms that came about just from poor power quality. So that is an important aspect of maintaining a healthy building, is having healthy power to every one of the pieces of equipment. Next slide. So in redundancy, the number one thing that we need to address is, what does the customer need? And that is evolving. Legacy data centers that are now housing AI servers are needing to increase the density of their cooling, sometimes change the type of the cooling from a classic under the floor through the rack, or a hot aisle, cold aisle that they're running, to maybe a direct chip type cooling. That's changing how much cooling equipment is needing, changing thresholds of where PUEs are, etc. But that redundancy still has to exist. The old automation redundancy thought was that we would have multiple controllers controlling one set of I/O, because controller life, reliability was a weak point. And some of the equipment, the physical machinery, was more reliable than the controller. Now that is not the case, and we have good reliability in the controllers, and so redundancy has become one controller for every piece of equipment that's controlling. And each controller has its own set of I/O for its own set of equipment. That way, everything is redundant, the controller and the piece of equipment. Also, our communication architecture with doing IP, even though the Siemens controllers have the ability to daisy chain their IP network, every controller is home run back to a monitored switch. And that way there's no failures that are unexpected in between one panel and another. If there is an interruption to IP, then we're minimizing the places that it could happen. Also, with the IP, we're getting data much faster than the MSTP, and we're also able to have peer-to-peer communication between controllers and real-time data that is shared from controller to controller without it needing to go through a front end or something like that. That way, every controller is aware of the points in its partner controller and is able to discern, is that point valid, or has it gone to a disturbed value, something that is no longer good, and I need to take a different course of action in its programming.
Holbrook Service also helped Siemens produce a redundancy guide and a programming template that is available to Siemens partners. So this is a tried and tested template. It's a step-to-step guide on maintaining redundancy to help simplify the process and to keep the modern standard for controller redundancy. So the biggest takeaway from redundancy is that if there's a failure in the equipment or the controller, other equipment can automatically adjust and switch to shift the load, back up the unit to avoid any temperature disturbances or unplanned downtime.
Next.
So energy and utility savings is a very important takeaway from this project. There is $176,000 in utilities saved. That was at the time of 2022. And then savings of 2 million kilowatt hours of energy, or just kilowatts of energy, and less service call expenses, and the ROI of 1 year.
And with that ROI, it's something that we've seen in some of the questions that were submitted prior to the webinar is budgeting. And so if we're able to achieve ROIs with intelligent programming and using the equipment to the best extent possible, it makes it easier to budget for these upgrades. Also, in attaining budgets, sometimes the mechanical budget may be smaller, but the IT budget may be bigger. With us having the capacity to do BACnet SC, where we can secure their BACnet network, we've seen some projects that have been able to be funded through the IT department's budget instead of it just being through the mechanical budget. So with redundancy and these migrations to newer technology, it opens up opportunities to look at different silos of funding. Next one. So some of the maintenance options that have come about from having this newer infrastructure is when they get an alarm, it's an actual alarm. With the MSTP network, the older system that was based on an N2 communication protocol, there were problems. There were many layers to get data from the controller through hubs and up into a front end that left a lot of chances for there to be false alarms. Now, whether a point is stale or it's an actual alarm, the facility knows it immediately. They're able to respond to the data, having the confidence that it's real data and they know what they need to do. But ultimately, reducing the number of service calls is the goal, because now the mission critical people can work on preventative maintenance, taking care of equipment, and making sure that everything is 100% and stable. This reduces their stress and also reduces the number of people that are needed to take care of a space. Nessa?
Sorry. We also have more data for mission critical. So they're responding to real time. They see all of their live temperatures right there in front of us, in front of them, because of the peer-to-peer communication of the controllers. So this means that there's more time for mission critical team to work on maintenance on projects instead of responding to the failure symptoms of their equipment. And then they also have live and historical trending on their alarms.
And we've got the Building X highlighted. Building X is a cloud platform that Siemens uses that allows for real-time data, customer dashboards, those sort of things. A lifecycle twin, which allows for augmented reality. You can walk virtually through your building, whether you're wearing augmented reality glasses or doing it on your laptop. And all of the values as you walk through the building are displayed, helping when they're doing rounds that you can have a perhaps untrained security person that's doing rounds as a regular procedure, but now on their augmented reality glasses, if there's a problem, it's lighting up in red, they're able to respond with calling the right mission critical people. It reduces some of the delays and inefficiencies of somebody manually having to look at pages of data. Helps in some of the project planning and getting a building, the BIM models all together. And when we're talking about the historical trending, Building X will trend in a change of value. These change of values are based on what you set up for reporting to your front end. But it also means that instead of a classic analytics site that is just doing a timed interval trending at 5, 10, 15 minutes and displaying that, where you may have valves that are repositioning, wearing themselves out, and you never actually see it because you only see snapshots. In Building X, you're seeing every change of value, whether it's temperature, analog outs, analog ins, which means every bit of information is being captured, and we're able to look at it with the analytics and determine if there's PIDs that need tuned to better, if there's a problem with fans or valves that's going to cause a physical failure much sooner than it would have. It also allows for us to have multi-site viewing for facilities that are distributed all over the United States or all over the world for that matter. Next slide. For security and expandability, we've seen some pictures of a couple of panels during the presentation. All of the I/O modules are replaceable and are able to be added to. That's important because no site is static. They're always growing, they're changing, equipment is being moved in, and new cooling equipment, new things to be monitored are being added. Instead of replacing an entire controller, an additional I/O module can be added. We're not changing any of the programming on the site. We're just adding a few points, which now means there's peace of mind for the customer because nothing changed from what was already working. Also, the I/O modules are able to be replaced in a hot swap. The module itself can be pulled out, leaving the I/O in place, or all of the wiring in place, and put back in without ever having to take the system offline. Meaning that having just a handful of I/O modules on the site gives them instant replacement, instant redundancy if the need arose, which ultimately reduces the project costs. It keeps the spare parts on hand to a minimum while providing a very high level of redundancy and security for the customer. Next.
So from the senior controls engineer at NOVVA Data Centers, Jeff Gray, he said in 2022 that they had not experienced any downtime with the PXC controllers in central plant for a year and a half. So that we see that trend to continue to grow into 2025 now. And then our outcomes, there's a faster response time to any data, any issues coming through, faster response time to replacement and service calls. The mission critical team is receiving real-time data immediately as it's happening. They're receiving energy and utility savings. They achieve zero downtime throughout this change-out process. Have had less service calls with the expenses associated with that, and then they can expand into the future with whatever projects come on the horizon.
And this particular site, they have engineered drawings right now for adding additional air-cooled chillers to the site to take care of customer needs. We're not going to need to change any of the primary controls equipment in order to facilitate this, which is a savings for the customer and peace of mind. My background started in mechanical service, and so being able to operate the equipment in a way that keeps the equipment dependable is important. And so making sure that our start stops are issues with the mechanical equipment is a piece of keeping the system online. As we talked about, having better trending and alarms is important. Building X that we're deploying with Siemens on their sites also allows for some real growth into the future with predictive failures, being able to have built into their digital twin all of the operation and maintenance manuals for everything. Being able to track valve actuations and repositions so that we can have predictive maintenance when we know we're at a certain percentage of the life cycle of a piece of equipment. Being able to have analytics that is looking constantly at a system and at how it's running so that we can see where the improvements can be made. Having the manpower to look at every sensor and every point would be overwhelming. So ultimately, the goal is happy clients, both for Holbrook Service, our customers, but the customers that have racks in their data centers, we also want to be happy.
And then peace of mind is a huge outcome. It's not something that NOVVA, the people at NOVVA have been able to put a price on. They very much enjoy getting a full night's sleep because they're not worried about the health of their data center. They know exactly, they have all of their data right there in front of them. So peace of mind is really a big takeaway from this.
All right, thank you very much. And now we'll hand it back to Lava.
All right. So David, Vanessa, thank you so much. That was a great topic. I think we're doing an audience poll question real quick. One more time, if you can participate, that'll be fantastic. So the question is, what are your biggest pain points or challenges in your mission critical facility or data center? There are a bunch of options over here, so please take a minute to find the one that applies to you. There's also a category other. Give it a couple of seconds. I think I see answers coming in. Looks like redundancy is the top as of now. So thank you so much for your participation once again. So let's continue on with looking at what Siemens has to offer. So you looked at or you listened to what David and Vanessa had shared about NOVVA Data Center and what they have done using Siemens products. At Siemens, we have a comprehensive product portfolio to support the data center cooling needs. Our Desigo PXC controllers that were used at NOVVA Data Center, just shared by David and Vanessa, they provide redundant application support for the most commonly found applications in data centers. Climatics controllers that are sold through our OEM channel, they provide equipment control for OEMs for the mechanical equipment. Our flow devices portfolio that comprises of intelligent valve, pressure independent control valve, butterfly ball, and globe valves, they control the flow of chill water and air, while our sensors measure temperature, flow, and pressure in the space. We also have a particulate sensor that can detect and measure contaminants to create an optimal air quality to protect sensitive IT equipment. Our building management software of Desigo CC and Desigo Optic, they can bring in alarms and other key information into easy visualization tools. We also support Tridium software for building management. In addition to that, we have created a data center redundancy solution using Desigo automation controllers. This is similar to what David and Vanessa had talked about at NOVVA. Vanessa mentioned the solution comprises of redundant applications to the commonly found cooling systems like chiller plants, air handling units, crack units, and other commonly found applications in data centers. We provide step-by-step instructions, diagrams, best practice documentation on how to create a redundant solution using Desigo PXC units. So it can be a faster way to get to your project if you can use the data center redundancy solution. Our solution also provides a data center focused visualization in Desigo Optic and Tridium with graphics and templates that can be used for easy implementation. So you can cut down your time to market. Data center specific alarms generated by the building can be managed in our building management systems, while we support built-in data center specific integrations of BACnet, Modbus, SNMP that are commonly used to bring in power systems, IT system, actually building systems as well, into building management systems in data centers. And all of this can be brought into Building X platform that David mentioned earlier to provide multi-site management, lifecycle twin capabilities, and sustainability reporting. We'll take a look at that as well. Our portfolio is constantly evolving to support the latest cooling innovations like we saw earlier, like the liquid cooling infrastructure. Siemens pressure independent control valves and intelligent valves directly support this liquid cooling technology, providing precision liquid flow control. And our portfolio is constantly being updated to meet the market needs with the stainless steel valves that are corrosion resistant and can be used in direct to chip cooling distribution units or rear door heat exchangers. The life cycle twin feature in Building X that David mentioned earlier is a digital twin software and can be used in data centers to design, manage workflow, and even for data center operations. Now let's take a quick look at the Building X lifecycle twin, a small demo that our data center customers can use. You can create, this is just an example, but you can create a digital twin using building information model and integrate the BMS, IT, and asset management information, all the data into to create a one version of truth. And facility managers, either by wearing those glasses that David was talking about or from remotely, they can take a look at the operations of the data center from anywhere. In this example, you see that one of the racks is sending an alarm that can be viewed visually in the digital building. You can click on the sensor history and to see where the problem started. You can go into asset data to see which rack has the sensor, and you can also access technical specs for the sensor in order to troubleshoot. You can see what kind of work orders were created, who is addressing them, and what kind of alarms were generated during this time. And this is just one of the examples of the life cycle twin. It can help with design, managing workflow, as well as the operations of a data center. Now, beyond the building automation portfolio, Siemens has a comprehensive portfolio that fits the data center needs, from grid protection to power distribution to cooling, fire and life safety, security and access solutions, along with many service opportunities to support data center lifecycle. You can scan the QR code over here to get more information on what we have as a Siemens portfolio. I'll give you a quick second, or maybe not. For you to scan the QR code, and then we will go into an audience poll question. Thanks for being with us and for your engagement. So now the question that we have for you, in light of today's increasing demands on mission critical data centers, can Siemens contact you to plan your building automation modernization? If you say yes, one of our Siemens representative will reach out to you to talk about what issues you have. It could be a consulting. So let us know if you're interested. All right. So if we keep moving, here are some resources that are available for you. To wrap all of this up, you can find the NOVVA Data Center full story here, like what David and Vanessa had shared. There is a lot more information. You can get more details on what exactly happened on this particular project. You can scan the QR code on the left-hand side. That'll take you to the NOVVA case study. To learn more about the Desigo building automation, you can scan the QR code that says Desigo Automation PXCs. We have an upcoming webinar next week on Tuesday, and the topic is data centers in the cloud, safe or risky, a super important topic. Security is the forefront for everybody on their mind. So please scan the QR code if you're interested to register and learn more. I know a lot of QR codes, sorry about that, but we have an engineering advantage program that can help your firm with the right resources. You can learn, you can scan the QR code over here and find our Siemens area or partner locator. and you can contact them, and they will be able to contact you if you're interested to get some lunch and learn sessions to learn about our portfolio. So a lot of good information over here. Let's take a quick second in case anyone wants to scan. And I guess we will have this recording if they want to scan again. So Mallory, the contact information. I'm Lava Pokala. I'm with Siemens, and we have David Carpenter's contact over here, as well as Vanessa Lucero. Thanks so much for your time today, and passing it off to Mallory.
Awesome. Thank you, Lava. And thank you to all the participants. We have gotten a lot of amazing questions that have come through today, and that we also have Fred Ross on the line, who has joined us as another data center technical expert. So I'm going to go ahead and get started with our questions for today. If David, Vanessa, Fred, Lava, if you want to turn on your cameras, we can go ahead and get started. So the first question is, how can I secure adaptability through AI integration for legacy data centers to minimize modernization costs?
So that question, hopefully I'm going to be able to answer it in the way that they're looking for. In the AI-based data centers, of course, the amount of cooling is significantly higher. So minimizing that is going to revolve around choosing the right control equipment and being able to maximize its capacities. In looking at the question a little bit closer, if they're talking about using AI to help with the programming, we found that AI can help with some sequences. It's a useful tool, but ultimately being able to communicate with your customer and discern the needs that they have is the ultimate tool. There's still a human aspect of this. And in our Building X portfolio, it is using AI more and more in that predictive failures and the analytics, which is going to help us to maintain the building better. So hopefully that covered all the aspects of using AI.
Awesome. Okay, thanks. Another one that has come through is, how does the system provide predictive failure for the mechanical parts that operate in conjunction with Siemens components? Anyone want to take that one?
Yeah, so we don't always know what's going to happen in the future. But the life cycle twin, it can help us expect the unexpected a little bit. We can look up submittal documents for valves and actuators. They tell us the estimated number of drives or actuations. So that can give us the ability to predict when the equipment will reach its end of life. So with updates and analytics, with the change of value, all the data is captured and you'll never miss an actuation count or change of value. You can set thresholds to send notifications when a piece of equipment is getting close to its end of life, like 90% of its lifespan has been used. So that way you can prepare for a replacement in the future.
Okay, some others that have come in. How is the real and historical trending and alarms handling improved, benefiting the owner?
I can take that one, Mallory. Trending, it actually real and historical trending, they generate a lot of data for storage and visualization. And alarms can create a lot of noise, making it harder to identify and prioritize critical events. So modern systems, software like Building X that David mentioned, they provide live dashboards with the capacity to store large data sets of every change of value on which, like Vanessa was saying earlier, we can run predictive maintenance that can be performed with recommendations on what corrective actions can be taken. Now, owners can benefit from these features that provide energy savings, and they can reduce their maintenance costs. I hope this helped.
Okay. Some others have come through. This might be for David and Vanessa. How did you achieve the energy savings? Is it by upgrading to more efficient motors, equipment, or using the existing components but with more optimized, optimized control?
That's a great question. As we commented, redundancy itself doesn't save money, but as we went through the building and we completed commissioning and went through the sequence in much more detail than had been, we ended up finding pieces of equipment that were running when there was no need for them to be running. Things that were quite literally wearing themselves out, but because the temperatures were still being achieved correctly, for years while doing maintenance, nobody noticed. And so we found those KW savings, and were able to trace back to when they started. And the building had been running that inefficiently for almost 12 years. So being able to have that real commissioning report that proves that we went through everything and that all of the sequence are operating correctly is important, but also the analytics that can look at things like, is there simultaneous heating and cooling? Do I have equipment on that should be lag and it's is showing status? Things like that that can provide a continuous commissioning afterwards is important.
Okay, we have
And
time for just a couple. Oh, go ahead. Go ahead.
sorry, Mallory. Finding things that are working inefficiently at buildings is something that we come across fairly often with old programming, just because things have been changed throughout the years or standards have been changed throughout the years, that when you start a change out process like this, that you can really dig into the meat of everything that's going on in the building. It does lead to energy savings because you're able to think about it more efficiently and on a wider scale.
Okay, thank you. Just a few more questions before we're up on time. Another one that came through, $176,000 in savings seems to be related to power savings. Can you please confirm, was there any savings on cooling water consumption?
Yes, that was 100% just in utility savings. Water savings, we did not have good data from before we took over. We do have water meters attached to and to the automation now for the cooling towers. But ultimately, NOVVA's other sites are all air-cooled chillers to reduce water consumption because a lot of their data centers are in areas where water is important when they're in desert Southwest and in high altitude desert. So ultimately, the chillers at this Colorado Springs site will be changed over to air-cooled also, in the effort to save and be more sustainable with natural resources like water.
Okay, and actually one more question on the topic of chillers. For expansion, if no changes on existing components or control systems, how does the existing system know, for example, a new chiller added to the system, and how does it control the new chiller to turn on, off, run on a schedule?
And that's a good question. We're not changing any of the primary controllers. We're just adding IOs for the new chillers that will be added. The redundancy guide that was built and the programming template was designed from the beginning to be expandable. So we can set the number of pieces of equipment, define which equipment is where, and that way that equipment will be rotated, monitored, and put into the lead lag cycles with the existing programming not needing to change.
Okay, and we had some more questions, but that is all the time we have for today. Thank you so much for joining us. Please use this QR code. I know one more QR code, but take our survey and provide us with your feedback on the webinar, and a recording will be available and sent to you via email within 24 hours. And please feel free to contact the presenters for any additional questions you have. Thank you so much for joining us today, and we all hope you have a great rest of your day. Take care.
Thank you.